So I'm gonna solve this problem. We solved the same problem almost last class, and we didn't need any of this dot product or anything like that. So let's just solve it, and then I'll show you how you use dot products to do this. The difference, there's two things different about this one than the one we did the other day. The degrees of incline of the ramp is different. I think the last one was 15 degrees. This time it's 30 degrees. This time, last time it was 600 pounds pulling up the ramp to keep it from going down, and we had to find the weight of the boat. This time they're telling us the weight of the boat is 600 pounds. Find the force that's needed to keep it from rolling down. So let's see. The way we looked at it the other day, we said, okay, we have to find, we have to find the force, right, that's required to pull that up when gravity is pulling down on a 600-pound boat. Okay, in order to do that, we need to have the component of gravity, which is parallel to that vector which is pulling up the ramp. Right, so we write the gravity vector as the resultant vector between one vector which is perpendicular to the ramp and one which is parallel to the ramp. Which means that's a 90-degree angle, and this is a right triangle. Okay. Now, right triangle trigonometry, I know the length of one side. I also know the angle, right? If the ramp is 30 degrees, then this angle is 30 degrees. Okay, now what am I trying to solve for? I'm trying to find the force, which is balancing that force. Right? So by finding this force, I'll solve my problem. I'll know how much we have to pull up to keep the boat from going down. So let's call that x, because that's what we don't know. Okay, which trig function will I use to find that side of the triangle? Sine, thank you. The sine of 30 equals x over 600. So x equals 600 sine 30. And sine of 30 is a half. So that's 300. So you would need to be pulling 300 pounds in that direction so that the boat doesn't go down the ramp. A 600-pound boat doesn't go down the ramp. Now again, we didn't use any dot products there at all. So if you want to see how they use dot products to do this, they introduced this concept of finding the projection of one vector onto another. And the formula is here. You know, essentially it would be like, for us, it would be trying to find the projection of the 600 pounds pulling down on a vector which is parallel to the ramp. It's kind of, you know, finding that one side of the right triangle that we did. And it has a formula. It is the F dot V, dot product, where F is the gravity, V would have been the vector which is parallel to the ramp. And then divided by the magnitude of the vector V times, that whole thing would be a scalar, times the vector V. And you know, you could certainly do all that, and you would end up getting this kind of a solution right here. Negative 300 there. So the magnitude of this force is 300, therefore a force of 300 pounds is required. I choose not to really do that. We know how to do this without getting into this projection, which I think would be a tough concept for us. And also because there's very few examples or very few problems to work with it, and then we would just leave it. So I'd just say, if you had to solve a problem like that, just make it right triangle trigonometry and solve it that way. It'd be much easier. Right? So